Bueno, thì đó là từ công việc liên công việc học tập liên cái chuyện với mà cái chuyện tên mình cái là chuyện mình phải được tiền cái gì đã dính vào bài
Oh, yeah, she come. What job boy shoot you on? Oh, yeah.
Hello, good afternoon.
Good afternoon,
Sir.
sir.
So you have been having a good day. Good to see you guys again.
Good afternoon, sir.
Good afternoon, sir.
Yeah, good afternoon, sir.
Good afternoon. Can you see my screen?
No, sir.
No, sir.
Can you see it now?
No, sir.
You can see it
No,
now.
sir.
No, sir.
No, sir.
No, sir.
Not even loading.
Okay, now we can see,
Sir,
sir.
we can see it.
Yes, sir.
Variation of acceleration due to gravity.
Yes, sir.
Note that for a body of mass m on the surface of the Earth, F is gm me over re squared, where r is the radius of the Earth, and g is the gravitational acceleration on the surface of the Earth. Now, what if the body is actually at a point r from the center of the Earth? That is distance r from the center of the Earth. Then f prime will be equal to gm me over r squared, which is mg prime. But you know that gm me is a constant. And from the equation 8.4, oh, that should be 2.4, that is mg re squared. Because you have an expression for, if you take a look at 2.6, you cancel m from both sides, of small m from both sides of 2.6. You arrive at capital G, capital M equals G small e re squared, right? Or if you leave it, just look at 2.6. Let re squared leave the denominator in under GM. Let it leave the position under GM ME. What will be on the right now? Small m GE re squared, right? That should be from equation 2.6, 8.4, 2.6. Is that okay? Can you see that?
Yes, sir. Yes, sir. Yes, sir. You can see, sir.
That means that f prime equals mge re squared over r squared, which will be equal to mg prime. Mg prime. We have seen that already from 2.7. Therefore, g prime equals r squared over r squared ge. Since r squared is a constant, g is also a constant. This is an inverse square law, just like Newton's law of gravitation, the force between two charges and things like that. They are all inverse square laws. Now, outside the Earth, r will be equal to re plus h. Assuming that the point is above the surface of the Earth, it's going to be re plus the height above the ground. So that means our g prime will now become re squared. Instead of writing r squared in 2.9, becomes re plus h all squared. Then ge. That will be 1 over 1 plus h over re all squared. We factor out re in the denominator. We now have re squared, right? What we have underneath? 1 plus h over re. Can you see that? Then re squared on
Yes,
top
sir.
is the re squared that comes from the bracket underneath. So what we have will be 1 over 1 plus h over h, 1 plus h over re all squared ge, which is 1 plus h over re to the power minus 2 ge. You're familiar with binomial expansion, right? The next thing, binomial expansion. This 1 to the power minus 2 minus 2 multiplying 1, then h over re appears for the first time. How many of us are not familiar with binomial expansion? That's binomial expansion. Is that okay?
No, sir.
You're not familiar with binomial expansion?
No, sir.
Okay, after the class, please pick it up. Is that okay?
Yes,
Okay,
sir.
sir.
No problem, sir. Thank you, sir.
Not take further maths in school, in secondary school.
No, we didn't.
All right. If h less than re, if h is much less than r, because the next time is going to be involving h squared over re squared. You know, if h over re is very small, then h over re all squared will be much, much smaller. Is that okay? Okay, take a look at 0.1. What is 0.1 squared? 0.01, right? What is 0.1 all squared? That is 0.01, right?
Yes, sir.
Yes, sir.
Which is much less than 0.1. In fact, it is 1/10 of 0.1. Now imagine it's even smaller than 0.1. Let's say 0.01. You take the square of 0.01, what you have? 10 to the power minus 4, right?
Now, yeah.
Which is even much, much smaller than 0.01. That's what we are talking about here. If h over r is very small, which is quite possible because the radius of the Earth is much larger than the height of the body above the ground, then we can neglect higher order terms in the expansion and write G prime equals 1 minus 2h over r e g e. Let's see how we got that from the last expression. That means we can just limit our expansion to this point. Higher order terms will be 0. You are left with only 1 minus 2h over re then ge. This is what you have in equation 211. However, inside the Earth, only the part of the Earth below the body contributes to the gravitational pull. That makes sense, right? Only the part of the Earth below the body contributes to the gravitational pull. Let the body be at a distance a from the center of the Earth. Then the effective mass of the Earth involved in the gravitational pull will just be equal to, that's the volume of that cube. What is the volume of a sphere? 4 over 3 pi r cubic, right? R in this case is A. So m prime equals 4 over 3 pi a cubic. But me itself is 4 over 3 pi re cubic, the whole of the radius of the Earth. Remember? You can now find the ratio m prime over me. M prime over m will be equal to 4 over 3 pi a cubic over 4 over 3 pi re cubic. 4 over 3 we cancel 4 over 3, pi we cancel pi over 3. And pi we cancel pi, we are left with only a cubic over re cubic. You can then write m prime as being equal to a cubic over re cubic me. Therefore, gravitational force inside the Earth, which we have labeled F prime prime, will be equal to gm m prime over a squared. You know, a is that distance of that body from the center of the Earth. This will be equal to gm over a squared multiplied by, instead of m prime, we write a cubic over re cubic me as we have seen in equation 2.12. That will give us AGMME over RE cubic, which we shall call mg prime prime, just as F equals mg, F prime equals mg prime, and F prime prime equals mg prime prime. For GME over RE squared is GE. Are you following so far? I've been deliberately slow.
Yes, sir.
Yes, sir.
Yes, sir.
And G prime prime is equal to A over RE GE. This is a linear function. What is a linear function? A is the only variable here, right?
Yes, sir.
GE is a constant. RE is also a constant. It's like GE over REA, where GE over RE is a constant. What would the graph look like? That would be a straight line through the origin. What's the equation of a straight line? Y equals mx plus c, right?
Yes, sir.
C. If c is 0, then that means that the linear graph is through the origin. The sketch of the functions is in the next figure. Inside the Earth, it's a linear function. Outside the Earth, it's an inverse square function. Can you understand that? Can you see that? You can see between 0 and RE, it's a linear function. Beyond RE, it's a square, inverse square law. That's the behavior of a function that is proportional to 1 over R squared. From RE, can you see from RE forward? The graph is dying down, right?
Yes, sir.
Yes, sir.
Relationship. Example 4, calculate the acceleration due to gravity 6,200 kilometers from the center of the Earth. What's the radius of the Earth? 6,400 kilometers, right?
700. Yes.
So this is inside the Earth. This is a point within the Earth. G prime prime is A over RE GE, which will be equal to 6200 over 6400 times 9.8, which is 9.549 meters per second square. You can see it is less than GE. Are you happy so far?
Yes, sir.
Yes. Yes,
Yes,
sir.
sir.
Very good.
No, sir. No, sir. Sir, please, can you go back to the previous slides? I didn't get
Okay,
the last part.
grandson. Is it granddaughter? Yes, granddaughter, what's the issue?
I didn't get the previous part, sir. But I can see it now.
Okay. So you're okay now. Any questions on this page? None.
Sir, question.
You can
Okay.
go over the. Yeah.
Hello, sir, please question. I didn't understand how the gradient of a straight line entered this.
Gradient of a straight line.
Yes, you mentioned y equals mx plus c. I don't know how it entered the.
Now look at G prime prime. Is G prime prime not A over R, G over REA plus 0?
Sir?
Look at G prime prime. The first two.
Okay.
Is that not G over RE multiplied by A?
Yes, sir.
Yes.
Is G over RE not a constant?
Yes, sir.
Yes,
It
sir.
is.
That's the M in Y equals MX plus C, where G prime prime is Y, X is A, M is G over RE, and C is 0.
In other words, so A is x-axis.
A is the distance from the center of the Earth.
Okay.
Look at that graph now. R goes from 0, it gets to RE, right?
Yes, sir.
Yes, sir.
So it is A from 0 to RE.
Oh, okay.
Thank
I
you.
understand, sir.
Calculate the gravitational field at a point 100 kilometers above the Earth. Take the radius of the Earth at 6,400 kilometers and the mass of the Earth 5.97 times 10 to the power 24 kilograms. The distance from the center of the Earth is 6,500 kilometers. right? Because the point is 100 kilometers above the Earth. Distances are measured to the center of the Earth. So G equals GM over R squared. Put all that together, you arrive at 9.4248 meters per second squared. Can you see that rather, is a maximum on the surface of the Earth? Can you see that?
Yes, sir.
Maximum on the surface of the Earth. Before you get to the surface of the Earth, you are coming from inside the Earth. It is less than G. Once you go above the Earth, it's also less than G.
But you're just coming from there. Okay.
Example 6. Find the gravitational potential of the Earth at a point 5 times the radius of the Earth. V equals minus GM over R. V equals to minus GM over R. Divide top and bottom by RE. You get minus GE RE over R over RE. So 9.8. Still, we sure that we're able to get R over RE from that formula. So that will give us minus 1.254 joules per kilogram.
Why are you going to?
Oh my God.
So please hold on a bit.
Now,
please, I have a question. The previous slide. The previous slide.
at what height above the Earth is gravitational potential of the Earth? Okay, let's see. That question is, of course, incomplete. That's what I'm trying to get out of that. At what height above the Earth, gravitational potential of the Earth minus 1.12 times 10 to the power 7 in the appropriate unit. Do you understand?
No, sir.
No. That should be in the question.
No,
sir. At what height above the Earth is gravitational potential of the Earth equal to minus 5.12 times 10 to the power 7 joules per kilogram? Do you understand? Okay, just look at that equation. R equals minus GM over R V of R, right? Which is equal to G M R E squared over R E squared, right? I just multiplied the numerator by R E squared and also divided by R E squared. Because I was not given the mass of the Earth. I was given only the gravitational constant. I mean the acceleration due to gravity, which is G. So what is GME squared? That is GE, right?
Yes, sir.
RE squared is GE. So this will give us minus GE RE squared over V. Put that together, we arrive at 784. That's 7.84.
There was somebody coming now.
7,840 kilometers from the center of the Earth. If you take the away from that, you get 7,840 kilometers minus 6,400 kilometers, which is 1,440 kilometers. At what height is the acceleration due to gravity due to the Earth? 1/6 that on the surface of the Earth. G over G will be equal to GM over R squared over GM over RE squared. That you can get from what we have been talking about concerning GE. What do we say G is? G is GME RE squared. So G will be what? GM R squared, right? While GE is GM RE squared. So G over G will be GM over R squared over GM over RE squared, which will be equal to RE over R all squared. which is 1/6. So R will be equal to square root of 6 RE squared. Put that together. There's a mistake there. The 6.4 times 10 to the power 6 should have been squared. You understand? Oh, no, it's okay. It's okay. But that 6.4 should no longer be under the square root sign. Is that okay? You should have got root 6. 6 times 6.4 times 10 to the power 6. Okay.
It's not okay, sir. It's not okay, sir.
Look at 6. Is that not 6? Square root of 6 times E?
Yeah, they wrote.
Just listen to me. Forget what they wrote.
Okay.
6 root of 6 RE squared will give you square root of 6 times RE, right? Hello?
Yes, sir.
Yes, sir.
So that should be root 6 times 6. The 6.4 times 10 to the power 6 should not be under the square root sign anymore. Is that okay now?
Yes, sir. Yes, sir.
So that's just it. Example 9, the acceleration due to gravity on the surface of the moon is 1.6 meter per second squared. Calculate the radius of the moon. Take its mass as 7.35 times 10 power 22 kilograms, of course. GM is GMM over RM squared, where RM is the radius of the moon. MM is the mass of the moon. So what is RM going to be? That's going to be square root of GMM over GM. G capital M over G. Put all that together, you arrive at 1,750,437 meters. Radius of the moon from our calculation. Are we happy?
Yes, sir.
Very happy, sir.
Very happy. That's great.
One happy.
Sorry, sir. I want to ask a question.
We are not happy.
Tell me why.
I may not understand, though.
Sir, please explain example 7, please. Sir, please explain example 7.
I don't understand.
Sir, example 7.
Bankai.
Please explain how in example 7 GM becomes GME RE square over RE square.
Yes, sir. So explain example 7.
Figure that out on your own. Okay.
Sorry, sir. I have a question.
Sir, do you have a question? Sir.
Yeah.
Okay, sir, please, in this number 8, where they ask us to find the height, are we going to multiply? Are we going to subtract this, what we got for R, from the radius of the Earth, since they asked us to find the height?
Which line is that?
Example 8, like the radius we got, the R we got, do we need to subtract it from radius of the Earth, since it's the
R is
height
not
they
gone.
asked to find?
R is not gone.
So I said the R we got.
RE over R you need. Okay?
Okay, sir.
I don't understand anything.
R is still there. RE is still there. Can you see that? Hello? Can you see that? Both R
Yes,
and
sir.
R.
Yes.
Are you okay now?
Yes, sir.
R is actually what you are trying to calculate.
Okay.
Any more questions?
Not at all.
I've not explained example 7.
Sir, please, I don't understand.
Example 7.
Yes, how GM turned to GM R square over R square.
That is very confusing, sir.
When you multiply and divide by the same thing,
Even the question is not complete.
Grandson.
Yeah, do you get?
Grandson. If you multiply by RE and divide by RE, have you done anything wrong?
No, sir.
That's because you wanted to bring out G, because G is GME RE squared. Okay, so everyone should be fine now.
Okay.
So let's now look at the relation of acceleration to the gravity with latitude. The body on the surface of the Earth rotates as the Earth rotates on its axis. As such, it must compensate for rotation with some of its weight. The body at latitude 5 degrees is on a circle of radius r equals re cos phi. You must have been taught this in longitudes and latitudes. The centripetal acceleration is therefore A equals omega squared r, but r in this case is re cos phi. Agreed? So if you are at the equator, what is phi? 0. It will just because omega squared re. If you are at the North Pole or the South Pole, phi will be 90 degrees. Should be? What is cos 90? 0.
Zero, sir.
On one spot. So there will be no need compensating for any centrifugal or centripetal force. What keeps a body in a circular motion? Centripetal force, right?
Force.
Not centrifugal force.
Yes, sir.
Force is a fictitious force due to the inertia of the body. Then the net weight is W equals mg minus m omega squared re cos phi, which is m into g minus omega squared re cos phi. So phi is 0 and the weight is mg minus omega squared re. For a body at either pole, as I've explained before, phi is 90 degrees and the weight is just equal to mg. Thus, a man weighs the maximum at the poles and least at the equator. Example, calculate the weight of a man of mass kilograms. 1 at the equator, 2 at the North Pole, 3 at 60 degrees parallel of latitude. At the equator, m into g minus omega squared re, that's going to give you 781.279 newtons. At the pole, W is just equal to mg, which is just 74 newtons. At 60 degrees parallel of latitude, W is going to be 72.64 newtons. The man weighs the most at the at the North Pole, and the least at the equator, because at the equator is using the largest proportion of his weight to compensate for rotation. Example 11: an astronaut is in a spaceship up to the Earth has a centripetal acceleration of 6 meters per second square. Calculate the height of the spaceship above the surface of the Earth. GMM over r squared equals ma. Notice that we are using r, not re, because that fellow is not r from the center of the, not re from the center of the Earth, but r, which implies that r squared is gm over a. So r will be equal to square root of gm over a. If you put all that together, you arrive at 8.19 and 6 meters. And h, that is the height above the Earth, will be r minus re, which is 1.79 times 10 to the power 6 kilometers. Weightlessness. When you're in an elevator moving up, there's a net force pushing you up. If the elevator is accelerating upwards, you feel the net force R equals M into G plus A. You must have been taught this under, an earlier topic, right? You have all been inside the lift, right?
Yes, sir.
House. Is there anyone here who has not been to Senate House? Or you are all attending your lectures at home?
Yes, sir.
Yes, sir.
This is Senate House. Yes, sir.
Let's take the lift. I know many of us have also taken the lift elsewhere.
So I don't understand.
Yes, sir.
Yes,
So
yes,
when you're
sir.
in the lift,
No.
so the lift
Yes,
is
sir.
initially at rest. On its way up, it will initially be at rest, right?
Yes.
Okay. Then it's going to accelerate upwards. If it's going to take off from the ground, then it must accelerate upwards. If you're accelerating upwards, A is positive. If the body is slowing down on its way up, A will be negative, which means that A is downwards, right? Otherwise, the lift won't be slowing down on its way up. That means there's a net force downwards for it to be slowing down on its way up, right? Yes. On its way down, it's going to accelerate from rest, right? But it will be accelerating negatively because it's coming down. A will be directed downwards. When it's about getting to rest on its way down, you know it's going to slow down to rest. That means that there must be a net force acting upwards, slowing it down so that it can come to rest. So I've not been taught the motion of a lift in an earlier class.
No.
Okay, you will see, I will send the whole of my notes to you.
Okay, sir.
Thank you, sir.
Thank you, sir.
It's my note. If it's not, I find a way of writing it to you. At least I have some notes that have it. So if the elevator is moving upwards, you feel a net force R equals M into G plus A. This is more than your weight, and you feel heavier. Who has experienced it before? It's as if a force is pushing you down. An extra force is pushing you down inside the elevator. This is because you are in a non-inertial frame of reference, and therefore there appears a fictitious force. M into A plus, okay, that will just be MA, not AG, MA, okay? Fictitious force MA. If you look at R equals M into G plus A, what is missing there is MA, right? R is MG plus MA, should be? R is
Yes,
MG
sir.
plus MA. So the fictitious force is AM or MA, right? Is that okay? The real weight
Yes.
is M. The fictitious force is MA. That's the extra force that is pushing you down. Where A is the acceleration of the elevator. If the elevator is slowing down its way up, then R will be equal to M into G minus A. You know, we said A will be negative, right? Downward. How do you feel? You feel lighter, as if the floor of the lift is being pulled off your feet. Who has experienced that? The fictitious force is now negative and is equal to minus MA. If you are on your own or way down and the elevator is picking up, R equals to G minus A. How do you feel? You feel as if the floor is being pulled off your feet. So you feel lighter. If the acceleration is equal to the acceleration, then A will be equal to G, right? And R will be equal to 0. You become weight. R is the apparent weight. If A is equal to G, the elevator is in free fall. When you say a body is in free fall,
When the force of gravity is not acting upon it.
When the only force is force of gravity.
when the only
When
When
the acceleration due to gravity.
force of gravity, right? Is that
Yes,
okay?
sir.
Yes, sir.
When you throw a body up, it is still in free fall. Even if it is going up, it is still in free fall. That's what I've explained now. The elevator is in free fall. That is, the only force on it is the force of gravity. If, for instance, the cable breaks, there's no reaction due only to a contact. You know, when you have a reaction, you get a reaction only when there's a contact force, right? If you are sitting on a bench, you are exerting a force, right? If the bench is not moving, Then the bench is exerting a reaction on your buttocks, right? Is that okay?
Yes.
Yeah,
How was Taye doing this?
this is your weight, right? If the bench is not moving, an equal and opposite force on you. Okay?
Yes, sir.
That's a contact force. But when, for instance, that bench were to be falling under gravity, if you are sitting on it, will there be a reaction? There will be no reaction, right?
Yes, sir.
Okay? What kind of force is that? Action at a distance. That's why gravity is action at a distance. So when the elevator is not yet falling at G, the bottom of the elevator exerted a contact force on you. But once it started falling with the acceleration due to the earth, the gravity of the earth, it stopped exerting on you. So no force on you anymore. Let's look at another situation. You are in a spaceship in orbit around that is not being powered. The only force acting on it is the force of gravity. That also is the force acting on you, and there is no reaction on your body, just as it is in the case with the lift when the cable breaks. You will float as you floated in the elevator. You and the spacecraft are in free fall, but you're able to maintain your orbit because of the tangential velocity of the spacecraft.
I'm sorry, sir. Please, can you go to the previous slide?
Line of it. Yeah? We are there already.
You have a pen. Yeah, it is fucking empty. I'm sorry. We can move on, sir. Thank you, sir.
Yeah, okay now.
Sorry, sir, I have a question.
Okay.
Hello, sir. Sorry to drag you back, sir. You said at the parallel of latitude, the weight is equal to what, sir? I didn't get the formula, sir.
Yeah.
Yeah. What's the formula of the weight at the parallel of latitude?
The weight.
Yes.
mg minus m omega squared r equals 5.
Okay.
Is that okay now?
Hold on.
Yeah?
Yes, sir. Thank you, sir. Thank you, sir. Yes, sir.
All right, I'm holding on. What is your thoughts? You just want me to hold on?
Yes, I can continue. You can continue.
We can continue, sir.
The gravitational force experienced by a body is given as F equals gmm over r squared, where m is in the field of the mass m. You see, capital M is creating the gravitational field, inside which is located small m. The gravitational field of mass m is gravitational force experienced by a unit mass. That is, G will be equal to gmm over r squared, all divided by small m. You know, small m will disappear from the expression in 215. Having been divided, 215 has been divided by small m again. So you get G equals gm over r squared. This is a vector given as G equals minus gm over r squared r cap. I'm sure you have been taught unit vectors.
Yes, sir.
The commonest
Yes,
unit
sir.
vector you're familiar with, I, J, and K, right?
Yes, sir.
Yes,
I
sir.
is along the x-axis, J is along the y-axis, K is along the z-axis.
Axis.
How did you get I? I is x vector divided by x magnitude. X vector divided by x magnitude. What will be the magnitude of I? 1, right?
Yes, sir. The unit vector.
The magnitude of a unit vector is 1. You can arrange to have a unit vector in any particular direction just by dividing the vector by its magnitude. So where R is the R capital unit vector pointing out radially from the mass capital M. Thus, gravitational field actually points towards the body. Why is it pointing towards the body? Because it's negative. G is a constant, right? M is a constant. R squared is also a constant for a particular radial distance from the Earth, right? From the center of the Earth, right?
Yes, sir. Yes, sir.
And they are all positive.
They are positive.
M is positive. R squared is, of course, positive.
See.
So minus GM over R squared, R cap is pointing opposite R cap, right?
Oh, yes. It's pointing.
Pointing opposite R cap. That means it's pointing towards the center of the body.
Of the body.
That's why the arrows you can see in that figure are pointing inwards. So wherever you are, the arrow is pointing inwards. That is why anywhere you are being attracted towards the center of the Earth. It's a non-uniform field directed towards and gets stronger and stronger as you approach M. You agree with that? Why is it a non-uniform field? What does a non-uniform field look? What does a uniform field look like?
That straight lines of force.
Thank you very much. Straight lines that are even parallel lines that are equally spaced, right?
Yes.
Parallel lines that are equally spaced. Why equally spaced? So that the magnitude will become constant. Why in the same direction? So that the magnitude, so that the directions will be in the same direction. We all have the same direction, right?
Yes.
Constant, if it is constant, both in magnitude and direction.
And
right?
Yes, sir.
Look at this one now. Are the field lines parallel?
No, sir.
What will happen is they get crowded more and more as you approach the center of the body, right?
They will meet at a point.
Approach the body, right? Approach the body.
Yes.
The lines are getting closer and closer, right? You can also see it from the equation. G equals GM squared. The smaller the R, the greater the G. So G is not constant.
Sorry, sir.
Yeah.
Can you take that again? Can you take it again? That statement. I didn't get it, sir.
G is not. Is G constant in magnitude?
No.
As R reduces, it gets bigger and bigger, right?
Bigger.
Okay.
Yes.
All right.
And stronger. As the distance from the radius of the Earth reduces.
Sorry, sir. There is another R prime there, like R bar. That equation 2.17.
You just joined the class, grandson. That R cap is a unit. It has magnitude 1, right? It only
yes, okay, it's clear now, sir. It's clear now.
Yeah, it only shows if it had been plus, it would have been pointing outwards from the center of the mass. It's a non-uniform field. We all agree, directed towards and towards the center, towards the stronger and stronger as we approach. Is someone snoring?
It's me.
Someone snoring? Is my class that boring?
No, sir. It's not.
No, sir.
Sir, that's not
No, sir.
snoring. That is probably
It's not
from
too
them.
boring, sir.
No, sir. No, sir.
The work done by the gravitational field in moving a mass.
No, sir.
I can't hear you, sir. Have you can hear?
Yeah, who can't hear?
Sir, we can't hear you.
Can't hear you, sir.
Yeah, I'm not certain. I've been busy trying to mute the grandson that is snoring.
Oh.
The work done by the gravitational field in moving RA to RB in the field of M equals integral from RA to RB. FDR equals minus GM. I will add a diagram to that. Minus GMN, integral from RA to RB, dr over R squared, which will be equal to GMM. Who cannot carry out that integration? What is integral of dr r to the power minus 2? That is minus 1 over R, right? Plus an arbitrary constant. If you are carrying out the integration between two limits, then the arbitrary constant can be ignored because it will cancel out plus and minus. Were you taught this in your secondary schools?
Yes, sir.
No, sir.
No, sir.
Okay.
No, they not teach us. So teach us.
Yes, no, sir. I wasn't
Sir,
taught.
this is not secondary school stuff, sir.
This is too advanced. It's too advanced.
We do is
For
minus
real, man.
W equals GMM into 1 over RA minus 1 over RB. This is GM. If you find the LCM, we are taking
Sir, we can't hear you, sir.
Sir, we can't hear you.
We can't hear you, sir. Or is it just me?
It's not just you, it's everybody.
It's not just you, it's everybody.
Let's chill first. Maybe it's doing something.
Who be this one?
Baby, it's Mike now. What kind of nonsense is this?
If you sing good songs, bro.
Hey, Olua.
Sorry, folks. I've been on a call. That's how I muted.
No problem, sir.
We stop here for the day.
So we can read
No,
on
sir.
this.
No, sir. No, sir.
Yes.
No, sir.
Let's
Let's continue. No, sir.
Yes, sir. Yes, sir. Yes,
Sir,
sir.
don't
Yes, sir.
stop the
Yes, sir.
class.
Yes, sir.
Continue. Sir,
Stop
continue.
them.
We can
Continue
just
the
end
class.
this here.
Continue.
Moses.
Continue with the class. That's the
Moses.
No, sir.
You don't do
Okay.
now. You don't do now.
Yeah, you are my darling.
Sorry,
Sir,
sorry,
please
thank you
continue
very
with the
much.
class.
Your class
Oh,
is
okay now.
your class has always
Let's stop, sir.
Yes, sir. Yes, sir. Yes, sir. Let's stop then.
body father
Sir,
from
we can stop here for now, sir.
You can
Sir, you need to
continue
stop
with
here
the
for
class.
now.
I
We
don't
can't
think
read more.
that's here, sir.
Sir, please, let's stop here for now. We can't read the notes.
Since there's no time, can still like explain for people that
It's
do not
okay now.
understand.
Let's hear
Your
word.
word.
Okay, so what are we doing now?
Yeah, I have a question.
Question.
Saide, please, I have a question.
So are we postponing or we are continuing?
You guys are making it. I
Man,
want to
don't
leave.
vex more.
Wow, he left.
I'm not sure about that. No.
He
Oh
left
yeah,
already.
he did.
Left.
Left already.
I don't even understand.
Oh, she got one
Now
bad
not get
Jerry.
class do before, no.
No, don't vex him.
I beg, data don't cost. Has the
Say,
lecturer
I
gone?
don't see 50 MB left.
That was good.
God, I beg.
So did he leave because he's angry or what?
Has the lecturer gone?
He has left.
No, now calm down, go. So calm down.
It's almost 3 o'clock. Almost 4 o'clock. What is almost commanding?
Ah, I see. If I still understand one thing.
I just said I would blame me. I just did second class, not 2.
I'm back now. Yeah, let's proceed with the class.
Oh, what goes
Let's
Welcome.
proceed. I mean, I will understand. Continue.
Let's hear what the tax cost. You meeting job.
Anybody can take over if you can teach us. So I don't understand.
Desperado. Mami.
Guys,
Who with that one? Who with that?
If na don't tire, I go come out yourself.
Desperado. Many.
Why the race?
Mami, go.
Baby,
Papa,
go what do?
taking me photo.
Yeah, be like say I go come out. Hello.
I'm back.
How we do from?
I never even drop attendance.
Jesus is coming soon. Oh, give your life to Christ. Jesus.
Anybody don't understand the class?
We should be saying Azal. Azal. Are you with them?
Akata's boys. Oh, Ghana. Oh, let's have a be now.
You go just land. You go land for black market. They go shotgun spoil your head.
Where you see black market for Akatas? You copying from?
Even the way I play concept.
Who they play football for you? Me we enter now.
Alcatraz. Now only Alcatraz they play for me.
But our tournament, yeah, yes. Sorry, the tournament is not available. Just the private.
Let me just take and sleep. It will be after the four. Like this.
Thank you for chairman.
1v1 sniper. Who is it?
Bro, I'm fucking in, fam.
Send your UID.
Man, drop out for chat.
Well, I need to calm down first.
Nah, we should show me one bit, so I don't do.
I beg I'm bottle.
Two of you against me now.
Hey, Mike would do.
Bro, that's what it go for.
Who is still recording like this? Okay, you are the one.
Fucking leave it, fam.
Who's today? Who's today class?
I did class.
Okay.
Is within.